Okay. Good afternoon and welcome, everyone. This is a monthly meeting put on by the Quattrone Center as part of a cooperative agreement we have with the Bureau of Justice Administration, Office of Justice Programs, to put on trainings and make programs available for folks who are doing post-conviction litigation through the wrongful conviction review and post-conviction DNA testing grants. So today I am just so happy to be joined by folks from Relativity, which is, well, they'll explain it much better than I, but a large corporation that works particularly in the legal field to help develop tools of AI and data management for law firms and nonprofit law firms to be able to help manage their data better and make their systems work better. So in light of the fact that the BJA solicitation will probably be coming out pretty soon, we wanted to get some ideas out for folks to kind of think of different ways, maybe in different projects, to think of in terms of making your own applications for that. So there have been a lot of incredible developments very quickly in the field of AI and data development, a lot of which is being led by the very folks you're going to hear from today. So Jonathan Hill works with Relativity as their social I'm not going to say social coordinator, Jonathan, because that's not quite right, but the coordinator for their social activism project called Justice for Change. And Nate is one of as I understand, a senior analyst with Relativity who has been helping and pretty very much involved in helping to develop some of their new AI platforms, which I'm hoping we'll get to see a little bit today. So I am going to go ahead and stop sharing. I am going to spotlight these folks for everybody so we can see. As always, if folks have questions that they want asked, please, excuse me, feel free to put them in the chat, and I will be happy to relay them to our participants. And just look, there you are, Jonathan. Okay. Okay. I'm going to go ahead and
Jonathan,
mute, turning it over.
can everyone see your screen? Good. Okay, awesome. Jonathan, I didn't know if you were going to say anything, but there is a slide in here on the Justice for Change program.
I
So,
was gonna say I will follow your lead and I'll hop in there, but go ahead, man.
okay,
Take it away. You're the
yeah. So,
exciting part of the
yeah, when
presentation.
I get to that slide, if you want to hop in and just say something real quick, that would be awesome.
Got you.
So, again, hi everybody. Thanks so much for the invitation. This is really awesome. I'm really happy to speak to everybody today. And kind of what I was going to focus on is sort of new generative AI tools we're developing both at Relativity, things that you might see in the industry, sort of considerations and advantages of each of these systems. And I'm not going to talk about, it's not going to be, I'm going to show you a few of them, but how I was thinking we would start is first, maybe what generative AI is, at a really high level, 101. Then I was going to briefly talk about our Justice for Change program and Relativity's AI principles. And then I was going to go a little bit deeper into all of this. So a little bit more on what's the underlying with generative AI, and then sort of three different use cases or different tools that are being developed across the industry to kind of tackle these problems. And hopefully some of them will be um, interesting to everybody here. Okay, so first, just at a really high level, what is generative AI? So I'm sure some of us have seen, especially in this past year, things like ChatGPT and GPT-4 have been kind of everywhere. But like in general, generative AI is just a form of AI where it has the ability to kind of produce content in a way that's fairly intuitive. Like you kind of input text and it will give you back text, images, or other forms of media. Um, and generally, the way that this works is it's using some complex models underneath the hood, which are neural networks, and I'll briefly talk about that. But typically, the way that these work is it's in response to some kind of prompt that was inputted by a user. And generally, that's usually like a text input, but not all the time. Okay. And again, how it operates is it's utilizing some complex machine learning algorithms underneath, and they are analyzing patterns, structures, and elements of the data. And they've been trained on massive amounts of data. So they're able to understand and create new content from what they've been trained on. So one visual I kind of included in here is this AI Prism. And I'll either share this deck so everybody has this, or maybe I will just maybe Google this like Gen AI Prism. And it's kind of a neat little diagram to kind of show you all of the technology that's currently out there to tackle different forms. So ChatGPT and GPT-4 are kind of more on the conversational text types of outputs, but if you're trying to generate things that are video content, sound, and other things like this, some of these other tools might be interesting to you. But what I'm going to focus on here in this talk are these sort of foundational models that they output text, and such as ChatGPT and GPT-4. And then I'm going to talk about a few applications to legal technology and how these tools might greatly impact the landscape of access to justice. Okay, cool. So now I'm going to talk about our Justice for Change program. So this, at Relativity, our Justice for Change provides our software, Relativity One, free to organizations that are tackling legal cases addressing racial and social justice. And it's really making a difference. So this past year, the Hawaii Innocence Project used Relativity to secure the exoneration of Ian Schweitzer, wrongfully convicted of murder 25 years ago. And over 30 nonprofits, and maybe Jonathan, maybe it's actually more now, I'm not up to date on the latest numbers of this, but over 30 nonprofits and law firms use our program to support pro bono matters addressing racial injustices.
Yeah.
Yeah.
I was just gonna say, Nathan, no, that was great, man. You definitely talked about the program in the appropriate way. I would say even more relevant for this community. We have about 12 innocence organizations currently leveraging Relativity across their cases and growing. Literally this morning received another application, which is fantastic. Two will be attending the Innocence Conference next week. So for those of you who will be in New Orleans after today's conversation, if you're interested in learning more about our program and tool, I definitely encourage you to visit our curbside consulting and booth. But the final thing that I'll call out, as Nathan alluded to here, is that, through this program, we really are looking at the community approach. While Relativity is donating 100 terabytes of its software to really tackle social and racial justice, I think what really makes this program special is the Relativity ecosystem that's gotten involved as well. So we have over 45 different organizations right now leveraging our software for cases, but we have over 35 different customers of Relativity. These are experts in our software that also raise their hands to say, hey, I want to provide some project management time for free. I want to host these cases. I want to offer some training for organizations just to ensure that that knowledge gap, which I'm sure that Nathan is obviously helping close right now, is addressed. And I think that's really something special about our program. But I'll turn it back over to you to talk a little bit more about our principles, because I think it grounds us in what our program is built on top of.
Yeah, that's awesome. Thanks for the segue, Jonathan. That's awesome. Yeah, so one thing that whenever we're trying to build new AI technology, there are a lot of things to consider, right? So the very first thing that we usually think of is, do we actually need AI to solve this particular problem? And if we do, what kinds of technologies and models should we use? On top of that, we need to evaluate it. Like, how well did it perform for my specific use case? Does it actually scale to all the workflows that I want to use this tool? Do I actually need real visibility on how the technology is making its decisions? Specifically, there are going to be use cases out there where that is really, really high priority. And is this use case actually ethical? So there's a lot of things that you actually have to consider when building new technology. And beyond this, there are a lot of really subtle considerations that can actually be forgotten if we're not really thoughtful about this process. And that's why at Relativity, we really take this seriously. And so we've developed these, which I'm going to show you in just a second, that we always point to when we're building these systems. And we encourage each other to really stop and question, hey, are we doing the right thing? And we when we're building all of these. So here are our AI principles at Relativity. So we build AI with purpose. We want our models fit for purpose in a way that we can understand, is it actually solving specific use cases that are delivering value. We empower our customers with clarity and control as much as possible. We're trying to explain that technology and understand and control what we can. We ensure fairness is at the front and center of our AI development, and privacy and security are extraordinarily important for us, especially when we're dealing with data that is extremely sensitive to our clients. And we act with a really high standard of accountability. So I'm really happy that we've, that we developed these AI principles and that we're free to kind of talk to each other about them all the time when we're building these new technologies. And I think it's really important that in general, people that are building this type of technology really kind of consider having these kinds of principles. And you will see that actually across a lot of different industries, that they will have somewhat similar principles, but not everybody. So definitely anyone that's building this, we always like to encourage them to make sure they're thinking about this. Okay, so now I want to dive into generative AI a little bit more, deep dive, but I'm going to still start off, a little bit high level, but then I'm going to kind of dive in deeper and kind of show you some of the inner workings of the technology that maybe you might not be aware of. So first, maybe you might want to know, like, what does GPT actually mean? Because we hear that all the time, like ChatGPT, GPT-4. So that's just short for generative pre-trained transformer. So the generative part, because it can actually like generate novel human-like content, it's very natural. Like if you've actually interacted with ChatGPT, you can see that sometimes it'll generate stuff that's pretty wild, but the fact that it's generating somewhat human-like content is kind of amazing. And the pre-trained part just means it's trained on massive amounts of data. That's why you can usually ask it questions about practically anything on the internet. It seems to be fairly aware of a lot of things because it's trained on massive amounts of data that is available on the internet. And that part is a type of neural network architecture that was developed not that long ago, like 2016, 2017 by Google. And it's a very specific type of neural network architecture that has taken over the landscape for anything in the natural language processing world. Okay, so I think
actually,
we've all
Nate, if I
kind of
can ask a question, I'm sorry.
Yes,
But
please
just
feel free
about
to
the
interrupt and ask questions.
yeah, I'm really good at that. But the types of data that it's used to train on, like I think you said, it's kind of it's not like specific. At least ChatGPT is not specific to, say, the legal community, right? It's not just trained on court opinions or briefs or anything else. So it's much broader than that, if I'm not mistaken.
Yes, so these kinds of models, they're called like foundation models, and they're trained on gigantic data sets, some of which might intersect some of these fields like legal technology. And that's why it actually definitely, I can assure you that it's been trained on certain legal textbooks that I have found that are open source. I've even asked it like to cite from a specific page legal textbook, and it can sometimes do that, and it's quite astonishing. So it definitely has been trained on much more than just like a legal library you might find on the internet. But yes, so part of what you're getting right here is usually when you ask a question, once you frame what domain you're talking about, it's just like when you're kind of conversing with humans, you kind of always give this background context, and that helps your mind get a mental model of, okay, I'm talking about this topic now, and you're able to have better recall about that topic. And I think that it's very similar when you're actually talking with these models that are trained on larger data sets. It's kind of, you build that foundation of which domain you're talking about, and then it's able to answer questions that are a little bit more specific. Yeah, that's a great point. Thanks for asking that. So probably the most natural interaction that we've had so far with ChatGPT is something like this. You're just asking for a question that you might just do a Google search for. What's a great place that I can grab some pizza in downtown Chicago? And then the result is sort of this natural human-like content where it's just providing for you, information about different places that you could go and eat. And it can be pretty useful for, what you're doing that day. But then here's kind of the interesting part. when you start to have this back and forth conversation with it, it takes into account your previous questions in its context, and it uses that, right? So now if I ask a follow-up, I'd rather just stay in tonight. Can you tell me how I can make a pizza like the one I could get from these places? And so now you're actually referring to the places, and maybe that is the context you're providing for the model. And now the model is going to try to replicate maybe a recipe that it might be aware of from the previous part of that conversation. Maybe not. That's the difficulty in terms of explaining what these models are doing. But as you get more sophisticated in your use case, you can definitely see that you've built up this context, and then you ask a follow-up about maybe the first thing you asked it, and it's quite neat and interactive on how it can actually recall some of this stuff. So what I'm kind of getting at here is a little bit of the structure of how you request data from something like ChatGPT and how it responds. So generally, the way that the interaction looks is like this. A user is providing an input, and that input might just be text that they write. Realizes that you can actually provide for it context beyond what you're writing. You can actually give it a whole document, right, as text data. And then you might ask questions about that document, and then it will actually respond, right? So when it does this, so we have kind of two major parts here. We have a user prompt, which is the inputs, all the inputs you give it, and then the response, everything that GPT will give you back. And within all of this text that's produced, this is what's called the context window of the model. And what that means is it's kind of like how much data it's actually able to handle at a given time. So there is a limit to how much data you can kind of give it and it can respond. You can't just give it, a million documents and then ask a question. I'm going to get to that problem in a little bit. That's a little bit more sophisticated, but what you should think of a context window as is kind of like it's short-term memory. You're asking a question on this thing, and it can only handle that much data at a given time. So every time you ask a question, there's sort of a limit to how much data you can cram into that question. And ChatGPT right now, the current version of it, can handle about 25 pages of content, which is actually quite a bit. But GPT-4 is a much, much more sophisticated model. This model was not only trained on text data, it actually is able to handle multimodal data. So it's actually able to, you're actually able to input images as well as text and ask questions about these. And that makes it not only more powerful in terms of the applications, but I'm going to show you in a little bit that it's much more powerful in many other ways. And not only can you input text and images like this, it actually can handle much, much more data. So the current version of GPT-4 can actually handle about 200 pages of content in a given single response. So you could give it 200 pages of content and then ask a question about that 200 pages of content, which is quite interesting. Yeah, I'm a little visual here, just because I think a lot of people don't realize that you can kind of do this. I think most people kind of interact with these models right now in just sort of the chat-like way. But once you start to take data that you're trying to ask questions about, then it makes this tool much, much more sophisticated and useful. So one of the things that got us fairly excited this past year about GPT-4 was its ability to a lot of legal problems. And one sort of benchmark on its ability to do this was early when they announced GPT-4, it turned out that there was a whole bunch of testing that was done. It was actually able to pass the uniform bar exam in the top 10%. And no other model that we know of right now has scored more than lowest 10% on that. So you can see right here, the ChatGPT and GPT-4, kind of the comparison of these performances in specific areas. And it's good at many other tasks as well that you might not be aware of. For example, it can handle multi-languages fairly well. It can actually do, sometimes you'll actually see in the news, like it's not actually the greatest at math. And the funny thing is sometimes it actually does make weird little arithmetic errors, but it actually can solve some really, really sophisticated math problems. In fact, I actually gave it, I used to teach math, and I gave it like some really high level math problems, and it was able to solve those too. So it could be a really interesting tool for just learning about a new domain. And that's actually one thing that I like to use it as a tool for.
Nathan, a question
Yeah,
we got in the chat going back to the 200 pages. Can the 200
yeah.
pages come from different sources?
Yeah, so I'm going to talk a little bit about how to scale this up. So like if let's say you want to use multiple different documents. Yeah, we're gonna talk about that in a little bit. So you definitely could do that. So like let's say you had 5 different documents you're interested in, and that's less than 200 pages. You could definitely paste all those in, and you could ask a question, hey, in here, can I find so and so, right? And great intuition, because that's exactly what my next question is right here. So
One
so
more
here's kind of
question
an
for you.
example.
One more
Yeah.
before you hop into this example, because you just touched on this. What's the underlying problem that causes it to miscalculate basic math?
Yeah, that is okay. So the way that these models work is um without going into the extreme complexities of the technology, the way that it kind of works is it uses all of the previous text that you've given it, and up to that point, you're kind of it's going to produce another token or another unit of text. And the very next unit of text that it generates is based on all of the previous units of text. And it kind of generates, it has sort of all these probabilities that are run. And it's like the most likely token, that's the next one, is this. And so sometimes I think with arithmetic, it probably just happens to be that the number that it's producing is just really close in probability to like another one. Like one time I asked it like a really complicated question, and then it said, 12 is not divisible by 4. And then I said, like 4 times 3 is 12. And I go, oh, I apologize, and it would fix itself. But I think it's really just with numbers, it's probably if the very next thing that it's going to produce is a number, probably there are 2 numbers that are really close in probability, and maybe both of them are not super high, like maybe both of them are like 40%, and it have to be in those borderline cases that it just messes up this kind of arithmetic. Yeah. But when it comes to a proof, I've had it actually solve ridiculously sophisticated proofs, and sometimes better than I was able to think about how to do that. And it could be kind of astonishing sometimes. So going back to like a legal application, a potential application, here is an example of maybe a QA application that you might use it for. Like maybe I'm trying to find some subtle signals of conversation. So let's say that I build a prompt like this, where the context, I'm going to give all the Slack messages between I just made up a name, Andy and Nate. I use my own name, right? So let's say I have all these Slack messages between Andy and Nate, and I'm allowed to, do this. Let's say that I paste that in as my context, and then I ask the question. So can you find me examples from this text where people are suggesting to change the communication channel or location? Sometimes you might call that like a change of venue. You're trying to detect maybe some wrongdoing is going on and they don't want to say it in Slack, right? So they're going to try to change the venue of that conversation. And the response might be, oh, there's actually a conversation where Andy says to Nate, don't talk about this here, text me instead. So what's neat about this is this is actually a hypothetical. I didn't actually paste, Slack messages between Andy and Nate. I'm just showing you something that I think you could theoretically use this for. What's neat about this is it could actually cite for you specific areas in those documents where there's evidence of what you're talking about. And then you can actually probe these models to give you much more insights than you might realize. Like we could actually ask it, okay, how do you know that other than the citations? What are your arguments for this? And yeah, so this is sort of the framing of what I want to get to next, which is, could we come up with applications that might be really useful for us in legal tech to solve certain use cases that seem reasonable? Okay, so let's say that you want to find answers on a much larger, whoops, sorry about that, on a much larger corpus. So suppose that we want to solve that exact same problem of gaining insights on documents, but you want to do it on an even larger corpus. So let's say that not just maybe Slack messages between Nate and Andy, maybe there were only like 5 of those. Let's say you want to look at all of my Slack messages, right? That corpus of content is much, much larger. Now, if you get to the point where the amount of data that you're trying to ask, say, GPT-4 about is beyond that context window I referred to, then we have to start talking about using that GPT-4 in addition to other types of technology. Okay, so what I'm going to talk about now are some potential solutions, one of which is, I'm going to talk about what the heck this is, but it's called retrieval augmented generation. And so what you're doing there is you're using GPT or some large language model in addition to another tool, and they're kind of working in chorus. And then the other 2 things that I'm going to talk about are some tools that we're currently working on. Air for Review is already out there well, it's in limited access right now, but it's not fully in GA of our software yet. But I'm just going to talk about a couple of tools that we're developing right now. So Air for Review is one, and another one that we're working on is building out custom models. Okay. All right, so very first one is retrieval augmented generation. So I'm going to keep coming back to this example and just show you how we would frame in these ways. So the first one is, again, okay, I have all these Slack messages. Can you find for me these type of conversations? When you do this, the output might actually be the same thing, but what's sophisticated is how much data you're analyzing now. That's the part that has grown significantly. So it's kind of like the same problem, and the response might actually be the same, but the amount of data you're handling is much larger. Okay, so I'm going to try to break this down with some visuals here. So what's actually happening is when you do this, your prompt is not actually going to end up using all of this data. Instead, what you're actually going to do is, in this visual here, that the original corpus you're asking these questions on, it just has like way too much data. So what we actually have to do is smartly figure out from this data, which things am I going to actually insert into that prompt. So you can see, like, I'm actually only going to send over these 2 components, or maybe these 2 documents or something like that. And the part of the prompt actually. And this prompt here is it's small enough to fit into that context window I referred to for GPT-4 to actually. Okay, so you're kind of ensuring that the data you're going to send the large language model, if I didn't actually say this before, like a large language model, GPT, that is just a type of large language model. That just means it's trained on a whole ton of data. Again, you can just think about it that way. And then you get your response back. So there's this intermediate step that I'm gonna draw a bunch of diagrams to help you understand this. Okay, so what's that intermediate step? So I have an original question, and what happens is that actually gets sent over to what's called an information retrieval model. And you can kind of think of that thing as like it's like Google search, right? When I search, there is a ranking of results that gets produced, and that's effectively what that does first. It's going to take your entire corpus of documents, and using your query, your original question, it is going to rank the documents in a specific way. Generally, what it usually does is it doesn't rank all the documents. It actually ranks passages from those documents. And the reason you want to do that is because if I have one document that's 300 pages, no matter what, if that's the most important one, I'm not going to be able to fit that into GPT-4's context. So what I actually have to do is I have to take every single document and I have to break it up into passages, and then we rank those. So that's why it says ranked passages from the documents. And feel free to stop me at any point if this is confusing or you have some question. This is not the simplest thing at all. And if it makes you feel better, I didn't know about any of this like 2 years ago, so don't worry. So the next thing that happens is, again, GPT-4, it has that context window. It can only handle so much data. So what we have to do is we actually have to build a cutoff point of how much data we're going to send over. So there's somewhere going to be this cutoff point. And then the top passages from those documents, that is what is going to be sent over to the large language model. So I'm not going to send over everything. I'm just going to send over maybe a few paragraphs from 100 different documents. And that gets sent over to the large language model. And then it tries to produce its response. And so the reason I wanted to draw it like this is because I think going those steps, you could probably already see there potentially could be some issues with using this type of technology, right? One of which is this big question. So what if there is something that got cut out? What if you're missing something, but it's really, really important for your use case, right? So that might be a really important consideration. Now, if you're just trying to get really early insights, maybe that's okay. Maybe that's something you can deal with later. Maybe there's another way you can validate what's remaining. But this is something you really have to keep in mind when you're using this type of technology is you are not going to be guaranteed that it captured everything that was important to you. It might capture some things, okay? Okay, so what I did for each of these little pieces of technology right before this call was I tried to bin some advantages and some considerations. I don't really want to call them disadvantages because each of them, I do think you can improve each of these systems and over time, the technology is going to evolve. So we'll probably be able to improve a lot of these considerations.
So Nate, actually,
Let's
on the
say
lines of improving, there's a question in the chat, which is
yeah,
about whether there's AI that can learn to read handwriting. So for this
yes.
group, many of their files are handwritten, right? Handwritten reports or notes from police officers or notes from witnesses or prosecutors. Can this technology read handwriting?
Yeah. In fact, so GPT-4, however, I was telling you that it's this multimodal model. I have done this before. You can take a picture if you have access to GPT-4. Um, and take a picture of it, and you can ask it questions about that picture. And it was my own notes. And one time I asked it to like reorganize the notes for me. It's not absolutely perfect at that because it's not like the level of technology like OCR where you're kind of scanning and it's converting. But it's surprising how well it can actually do with handwritten text. Like one time I'm just again, what I'm telling you right now is anecdotal evidence, but I'm pretty sure that you could probably build some technology that might be able to analyze some of that, but I would want to validate that, of course, that is a potential application of this for sure, I think. Um, but yeah, I have done some limited like my own testing. I haven't done this for relativity, just handwritten tests. Yeah. Okay, so some advantages of this system is really one of the reasons that I think ChatGPT kind of took off is it's fairly intuitive, this QA process of like getting feedback, asking questions, and that workflow is pretty intuitive. And we've heard from, attorneys that have used this tool or others using this tool that that type of interaction is pretty intuitive. So building tooling like that is something people are interested in for sure. So one other thing is that it can accommodate many different use cases, right? That is an advantage, but it also could be a disadvantage. And I'm going to talk about that in just a second. It can cite from the original documents. That can also lead to a disadvantage I'm going to talk about. And it can be fast at finding some initial insights. Okay, so some considerations here that are related to these things is in some sense, it actually requires a lot more training and prompt engineering. So you kind of have to be really good at figuring out how do I actually frame this question to solve a problem that I'm interested in. So if you're really good and interested in the prompt engineering side, this is the type of tool that might actually help you with that. One of the other considerations is that it's not going to necessarily give you clear explanation or considerations of those model results. So you might get a result, but then you might not know, well, how did it get that result or what's going on here, right? When you're applying this to specific use cases, it can be a lot harder to replicate those across multiple workflows. So what I mean is maybe you find a prompt to solve a problem in one way, but when you go to use that same prompt with other data and other workflows, maybe it doesn't behave the way that you expected it to. So getting that correct and those prompts correct and then evaluating them is a huge, it's a lot of work. And the next tool I'm going to talk about, that was a huge component of actually developing AIR for review.
Well, I'm sorry, Nate, this is
Yeah.
a little bit of a couple steps backwards, but so it sounds like, and you mentioned OCR before. So what a large language model, and please correct me when I say this wrong, is not just looking for words. but it is actually able to identify concepts and pull information together to answer more complex questions. Is that fair to say? So, for example,
Yes.
for this group, if we
Mhm,
wanted to say, okay, here's a case file, I want to know what kind of eyewitness identification there was.
mhm.
It's not that it's going to look through and look for the words witness identification, but will look for the
Yeah.
concept and be able to tell me an answer. Is
Yes.
that,
So what
am
you're
I saying
getting at
that
is
correctly?
actually, yes, that is one huge advantage of this is normally when you talk with these models, you can use natural language concepts and without having to necessarily use keywords and things like that. So that is another component of the of how nice these systems are. I should have actually added that as another advantage here. I was going to add it to the third piece of tech. Well, the other, actually all three of them. In a lot of ways, all of the descriptions you're providing are very they're really written in natural language. So we're moving kind of away from necessarily needing, getting those keywords just right. And sometimes those keywords are not going to hit on certain things that you would have missed otherwise, right? Like when you're talking about change of venue, our original example, you might not there might be modes that people are kind of speaking in, or they're using coded language, and you're not going to get that from search terms, right? Kind of the context of the conversation and um, the behaviors. Yeah, it's all in there. Um, okay. Another thing to consider is it's a little bit harder to validate what you missed. We kind of talked about that. And even though that you're citing sources, these models can still hallucinate. And what that just means is that, as you probably have seen in the news and sometimes, that there are ways that these models will produce things that can be essentially made up or hallucinated, right? So it's very important to have that step of validating, okay, I have this information, it looks extremely useful, but am I absolutely certain that it's actually real? Can I confirm that? Sometimes the confirmation could be really simple because I could get a citation and then I could just copy and paste it. But it'd be really nice if we build systems that make that front and center as a part of it. And while it may be good at finding a few insights, if I needed to find all those insights on a really large batch of documents, that's going to require a completely different kind of workflow. So like if I need an analysis done on every single document in the same exact way, you're going to have to use a different tool. Okay. So again, there are definitely advantages and disadvantages for each of these. So I just kind of wanted to write these out. Okay. So Air for Review, what we're doing with Air for Review is trying to solve some very specific use cases. One of them is, can I identify relevant documents in a review? Can I code for issues, and can I find key documents? You can take these workflows and frame them in ways that we're kind of talking about right here, which is maybe I'm looking for instances where people are suggesting the change in communication channel. And what I'm doing in Air for Review that's a little bit different from this Q&A experience is we're kind of taking you through a guided step-by-step process. So what you actually have to do is you have to fill in all of these little details about what you're looking for. We specifically require two. One of them is you have to give us some kind of domain background about what is the matter, or what is the domain of things that I'm exploring here. So in this case, you would probably say, I'm looking at Slack messages, and then your relevance would be exactly, I could probably just write this, exactly what I'm looking for. But the point is that we are trying to guide you through a use case that's well-defined and it's replicatable, okay? And here are a couple of insights on what the inputs and outputs look like, or what they're doing. And then I'm going to show you at the document level what it actually kind of looks like. So the inputs, or kind of like your prompt, is effectively built from three things. One of which is instructions that Relativity has written and has validated across many different matters. Okay. The second thing is what the user sees. The user will put in those inputs, just like I showed you on the previous slide, sort of like guided inputs, and we have suggestions on what you might put. And then the last thing is the document that you're going to analyze. Now, if you do this in batches, each of those documents are going to be analyzed one by one. And then the output for every single document is going to be citations from the document for where the model thinks that this citation specifically makes that document responsive for some particular reason. We give rationale for why the model is making that decision, and we also provide considerations. So we have considerations where what the model might have been confused by here, why might it be incorrect, and that might really help you realize I actually am not providing this type of context that's really needed to do this analysis. So it really helps in that sort of iterative feedback. And then the last thing is we provide a recommendation for whether or not this document you're looking at is actually relevant to this thing that you're looking for. And then the very last step that's really important is that we actually are validating those citations that are pulled out from the source document, and we're validating them using a tool that's completely independent of one of these large language models like GPT-4. So we're actually using tooling to validate it that's independent from the large language model, because we think that that's extremely important to ensure that these models are not hallucinating. So we're building in sort of that step to validate this. On the document level, it looks like this. So everything that I just said. So here is your document here. It is pulling out citations and highlighting them, specifically what is making this document relevant. And there might be multiple citations for that. It's providing a recommendation for why it might be responsive, rationale and considerations. So this, again, is to give you some insights of how the model is making a decision. So it's explaining itself. And then finally, we're validating that these citations are really actually in that document. So when you see this highlighting, that's not a hallucination. It's actually in there. Okay, so some advantages and considerations for Air for Review. So one of the advantages is that the user is guided through a fit for purpose and repeatable workflow for very, very specific use cases. So we don't as much have to worry about the prompt engineering phase, but I'm going to talk about that in just a second. Recommendations are provided with an explained detail on the model and how it's making its decision. Citations are validated independently of the large language model to confirm that they're not hallucinations. And this is repeatable on large batches of documents with consistent and defensible outputs. Now, on the consideration side, because you're actually analyzing all of your documents for specific insights, you can't currently, the way that this technology is, we can't really just do that analysis on a million documents. It's going to take a little while for that technology to scale up to that. You know, all of this is a little bit new. So I think that that will improve over time, but we're probably going to need some additional tools to first have sort of a queuing mechanism to feed into this tool. And yeah, while less sophistication is needed for knowing how to do the prompt engineering, like I said before with the Q&A, users still are going to be getting used to a completely new workflow. I mean, as we always do with new technology. Okay, so that's what I have for Air for Review. Happy to answer any questions as they come up. Last thing I want to talk about is custom models. So the idea here is, I think some of us are probably familiar with what sentiment analysis is, but generally what you're doing here is you're trying to look at documents and you're trying to identify where are there positive remarks, where there are negative remarks, or things aligned with those kinds of statements. And obviously that is somewhat subjective, right? So when you build some of these models, they can behave in sort of a little bit unexpected ways. Or what actually happens is sometimes you might want to find, say, documents that have negative sentiment in it, but you want to be very, very specific on the type of negative sentiment. Maybe you don't want just negative sentiment, but maybe you're trying to find someone's angry about some very, very specific thing, but you could describe it in natural language. So what I'm getting at here is going back to our original problem again, right? Our original problem is, here's all of Nate's Slack messages. Can you find for me examples where people are suggesting change in communication or changing the communication channel? What we're actually trying to do is reframe sentiment to cover more general signals here, right? So the signal that I'm looking for is, I can describe what I'm kind of looking for in natural language, but the actual examples themselves of what I'm looking for are different than what I'm typing in there, right? Like different than what I'm actually describing. So actual examples would look like this, right? So we need to be careful. Let's talk about this at lunch and not here. So when I say positive, I don't mean positive sentiment. I mean that is an example of something that I would say that's change of venue. That's an example of what I'm looking for. I just saw others talking about it. Text me right now. I'm on my phone. I'm worried. So again, change of venue. They're talking about this. And an example that would not be change of venue is just something, did you get my feedback? We should discuss this. They're not trying to change the mode of communication there. So the idea behind custom models is, if I can describe what I'm looking for in sort of natural language, can I build a list of sort of training data to then build something like sentiment that would be like a custom model that I can then apply and find in my documents instances where I see that kind of communication happening, right? And it doesn't have to be communication. It could be definitions for a category of documents have kind of clause in it, anything you can think of that you can naturally search for or describe in natural language, but you think you could probably produce some examples. Okay. So again, these examples that are produced are not dependent on your documents or corpus that you're providing. They're just examples where the user can go in and confirm, if I saw that, I would agree it looks like it. And if it isn't, then I disagree. And so the only thing that I didn't draw in this diagram is the last step is you would actually take this corpus and we're actually going to rank it and find instances of things that you're looking for.
So that's Nate, kind of like your way of training it on top of its own training.
Exactly.
Cool.
And the cool thing about this is, if you build one of these models, you can then the idea is you should use them, because this data here that you're using to train it is all synthetic data. It's not part of like an actual corpus. So it should be reusable. Okay, now how this would look like, this is just a design. If you're really interested, I can hop in Relativity 1 and show you in a test space. It actually does look a lot like this, but just not the first phase here. So here is what it would look like, if I were to generate some examples of positive remarks about another person's performance at work. That would be an example of a way that I could describe that in natural language, but the examples that I'm looking for are different than the actual description, right? So we're kind of separating these. So here's some examples, right? So the user, you can think of the user kind of going in and kind of confirming or denying, are these kind of what I'm looking for, right? So they would go in and label these. And then from there, behind the scenes, once you do that, it would train a model, and that model will provide two things for you. Every single document will have a score associated to it, and it will have a passage that is the passage that's most likely to contain that signal that you're looking for. So you kind of can think of this as a ranking, and I could sort on this, and then I can look for specific places in these documents that have these kinds of signals. And the nice thing about this is well, here are some advantages and considerations. So the first one is that it's fast at scale. It just has to be architected the correct way. It's flexible to help find specific user defined signals using natural language. And I will say that the previous technologies are also like that. You can still define them using natural language. The citations are pulled from the documents in the form of passages and snippets. So that also is somewhat similar to the previous technology, but the fact that I can do this on millions of documents at scale is the thing that kind of separates this tool from those ones a little bit. And it also produces a score, which can help with different kinds of workflows. Maybe you're only going to look for things that are above a certain score or something like that. So, and it's also kind of helping with the explaining it a little bit. Less explainability is a consideration on this model because it really is only giving you the scores and the snippets, but the user is very much still involved in validating this. And another huge thing here with all AI technology and search AI that you have to consider is how to use these models ethically, right? So this is true really for all technology, but so more on the explainability of these models and insights on how they behave for their intended purposes is really important when you're developing these.
Yeah.
And that is, I think that's the last slide. Happy to go back, talk about any of
that
the
was
individual
when the way we got
technologies
the case was
or,
a mother called and spoke
yeah.
to
I
Carolyn
remember, yeah.
and said,
Awesome. Thank you so much, Nathan. I'm happy to facilitate any questions that get dropped in the chat. We're also happy to talk a little bit more about our Justice for Change program, but I think really, alluded to in this entire conversation is that a lot is being done in the AI space. Relativity is just, one fish in this huge pond that's continuing to grow. But I think it's really important that one, as an organization, that you are grounded in principles, that you're able to talk to different groups, whether they're your day-to-day constituents or not, recognizing that for Relativity, we're typically working with large law firms, service providers, government entities, and making sure that they can leverage our tool for large and complex litigation. But what does it mean for an innocence organization for them to also have access to similar tools to help you do your work? I think even as you were talking, I thought about one thing on the sentiment analysis. I was like, gosh, how many times I hear someone in the Innocence Network mention that they're looking at, interviews between witnesses and they're trying to find coercive language or different things of that nature. So just to be able to know that that is a future that hopefully our technology will be able to solve those kinds of problems is exciting. But know that we can't do this work unless you help us understand what data is out there, what are the challenges that you're having on a day to day. So we're super grateful for the chance to be here and for Marissa, you inviting us to be part of this conversation. But we're happy to answer any questions.
So, folks, if you have questions for Jonathan about the Justice for Change program, and I apologize, that's really more toward the innocence organization folks, the necessary CIUs, because as I understand that Relativity is not at this point working with government agencies under that program, or just about the AI itself and how it might be tooled. One thing I'm looking at, and this is probably more for you, Nate, it looks like ChatGPT-4 or GPT-4 requires like a monthly subscription to be able to do that uploading of documents that you said. But let's say I have a case of my own and I want to figure out where's all the exculpatory evidence or where's the inculpatory evidence or like we're saying what kind of eyewitness identification. So if I upload all my case file, I should be able to somewhat reliably ask it questions along those kind of like to help me screen the case. Is that possible?
Okay, so right now in Relativity, the Air for Review program is not fully in GA yet. It's like not fully available, so we're kind of like rolling that out. But I mean, we're hoping that we can use that technology in the near future. It's all within Relativity's universe.
Okay.
So when people upload documents, you can ensure that the security of those documents is well maintained within the Relativity universe. If you're talking about using it on your own, for your own use cases, as long as it's not data that you aren't okay, putting into the one problem is when you're using it on your own, if it's just like a paid, if you pay like the $20 a month for the pro user account, that's just like you're talking about that data specifically with OpenAI, and that data could theoretically be used for like you don't know what they're going to do with that data.
Got it.
I kind of am a little hesitant to what I usually put in there because you don't want to put like personal information in there. But within the Relativity universe, all of the data that gets interacted with these sort of models through a very secure API.
Right.
Any of that data is never shared. It's never reused by Microsoft or sent over to OpenAI to retrain those models. The way those models work is like this very, very specific instance where the data gets sent through it's called an API And you kind of have this interaction with the model, and as soon as it sends you a response, it forgets that it ever had that interaction with you, except for if you happen to provide, the previous context again in the next interaction. So it's kind
Got
of
it.
like this model that is forgetful. It's like, in a sense. I don't know if that kind of answers your question, but it's kind of like,
Yep.
it's like a yes and a
That's
no, but then
perfect.
there's all these sort of security
Right.
concerns that I would have about actually using that tooling. But I will say that we're kind of rolling out this airflow review technology very soon. And uh, yeah, I don't
Okay.
know. Does that answer your question, Marissa? I'm
Yes.
sorry.
Yes, it absolutely does. Thank
Okay.
you.
Mindful of time, we did get another question in the chat. Can this technology be used for providing summaries of transcripts?
Okay, that problem is quite interesting. I was trying to solve that problem actually. So transcripts can typically be extremely long. So what you would usually do is you would try to chunk that up and then um, maybe summarize these chunks. So you might take, transcript and break it up into some smaller sub transcripts and then use that. That is something that we're trying to work on. One workflow that could potentially help is very similar to that RAG workflow that I referred to, where there are a bunch of people trying to build that exact same thing, like summarizing transcripts, asking questions on these transcripts. Yeah, that's very much on our radar, but that's not currently. We have a product in error per case strategy that we're working on that is it's in alignment with that problem. But yeah, it's in the
Great.
works.
Okay.
And lastly, Marissa, before we hop off, if there are no other questions, and selfishly, Nate, tell me if I cannot do this. I encourage you all, if there are any other questions, please reach out to us. Recognize that we love the Innocence Networking community. We love everything that the team here is doing to just upskill this entire audience. So if there's a role that we can play, if there's a follow-up question you have, if you didn't think this was the right environment or we didn't talk about it the right way, let us know, because we want to play not only active partners, but responsible partners in this work.
Right. And then we do
Thanks
usually
so
go
much.
till 3:15. So if folks do
Oh,
still have questions, we do still have
Perfect.
time, unless Jonathan and Nate need to hop off. But I'm very cognizant, Nate, of what you were saying before about making sure that even if you're using kind of one of the open source programs, to being aware that the information that you're feeding into it is not, protected by any means, is not something that particularly private, unless you're able to kind of put those blinders on it and somehow. So I think that's something that is worth kind of repeating and making sure that folks understand that yes, it's out there, yes, you can use it, but you can't control where the data goes once you enter it.
Yeah. Yeah, I would definitely agree with that. I mean, that's one of the reasons we were able to even utilize this technology is because it's within Azure, which is where, Relativity lives within Azure. And so we're able to do all of this securely because Microsoft has that partnership with OpenAI and with us. So
Right. And just folks, I'm not encouraging people to jump off at all. We love more questions, but yeah, I am posting the poll for us to get a sense of how helpful this was to you. And also, if you have topics that you would like us to cover in future meetings, please let us know through that. And there's a new question in the chat for you, Jonathan.
I can take this one here. The question is as it relates to what was Relativity's involvement in the Ian Switzer case. I can tell you our AI tool was not around at that time, unfortunately, though I know that we would have loved for it to be leveraged in that case. But just a little bit of context and background there. The Hawaii Innocence Project, as well as the Innocence Project, applied for the grant. They were over 5,000 miles apart, over 36 bankers, boxes of documents, and we're able to leverage Relativity through a partnership with one of our hosting partners, as I alluded to earlier, Complete Discovery Source, to not only collaborate and review those documents simultaneously, but I think the ability to rely on Relativity for such things like DT searches when you need them in real time, whether it's 24 hours before you're heading to the courtroom, and or again, you're just preparing for any type of meetings with opposition, we want to make sure that you can rely on a tool that can help you sift through the documents that you do have. And I think that's a huge benefit and asset of the Relativity platform. But obviously, it's only a fraction of its true power. And that's what I really love about Relativity and what we're doing through this program. You're not getting a light version of Relativity if you get the grant, you're getting the full capabilities of our tool. So I know that we've talked a lot about our AI features and capabilities today. I'll tell you, and knock on wood, Marissa knows this, I'm advocating. I cannot wait until it gets into GA so that we can put this in the hands of some of our nonprofit organizations. But these are the types of discussions that I think not only encourage it, but really make sure that our leadership knows that, okay, there actually is a use case. Going back to what Nate was talking about earlier, I think we're only scratching the surface.
Other questions from folks to throw at our very kind guests who've joined us today? Okay, so Jonathan, I'm putting you on the spot just a bit. Would you mind putting your email in the chat so people could contact you directly if they do have questions about that and want to kind of follow up? And there's a question there that's asking, did you say you'd be at the Innocence Network conference? My understanding is that yes, Relatively is going to be there.
That is correct. I just put my email there in the chat. Relativity will have a presence at the conference. I fly in on what's that, Thursday evening. So day one we won't be there, but that Friday and Saturday, please visit us at the Curbside Consulting booth. I believe you can now sign up for one-on-one sessions. So please go ahead and sign up soon. I already have seen they're starting to fill up quite fast. And then also recognize that, like, again, myself, Nate, we can make ourselves available for a discussion if it's of interest to you. My biggest thing and my biggest ask always in these spaces is, feel free to obviously ask to leverage the software for these programs, but also come to make us a little bit better. So bring your biggest challenges and issues and let's figure out if Relativity is the right tool, because if it is not, I do not ever want us to be a barrier of access to justice. We'll point you in a better direction. But for the most part, I believe we've been able to solve some really complex issues amongst the Innocence Network.
Mm-hmm. Okay, I think the questions seem to have calmed down a bit. Oh, wait, there we go. Ask your community what models you would build. Can we ask your community what models you would build?
That's from the Relativity side.
Oh, okay, sorry.
Yeah, sorry. I can come off mute and say that. People who are on the call, when you hear that we're like building custom models and stuff, I'm some of them will go into the Relativity model library. So is any of this inspiring? What comes to mind? What kind of models would you build if you had this capability?
Yeah, and by the way, this is Kay. She's leading that project now. So awesome.
Hi, Kay.
Oh yeah. Hi.
So I guess that's for folks who are still on the call. If you had the ability to have your AI do anything for you in this space, do you have a thought of what that would be?
I know it's a very open-ended question for the end of the meeting. Send us an email if something comes up later.
Okay. Or you can feel free to reach out to us at the Quattrone Center and we'll be happy to kind of compile that to be able to get it back. Great. Okay. So I think we are winding down. I want to thank Kay and Jonathan and Nate so much for your time. This was very, very helpful for all of us, and especially your generosity of spirit to be able to talk about what's available out there for free, as well as, of course, about the very hard work that y'all have been doing at Relativity. We're very grateful for your time. For everybody else, we will see you next month, same time, same bat channel, on a different topic. But it's great for you all to join us, and thanks so much for being here.
Thank you all.
Thanks so much.